The Being an Engineer podcast is a repository for industry knowledge and a tool through which engineers learn about and connect with relevant companies, technologies, people, resources, and opportunities. Enjoy the show.
As an outside looking in, we're an engineering services company, but inside these four walls, we're a people development company.
Hello and welcome to another episode of the Being an Engineer podcast. Our guest today is Robert States, who holds a bachelor's degree in plastics engineering and an MBA from Penn State. Robert is a principal at Stress Engineering Services, where he and his team provide comprehensive design, analysis, and testing services to industries from plastics to packaging, materials to testing, medical to pharmaceutical, pipelines to power, and measurements to forensics. Robert, thank you so much for joining us today.
Thank you for having me.
Well, how did you decide to become an engineer?
I was always liked math and solving problems. And in Penn State, the campus I went to was closer to my house than my high school. So I went up there. I took classes when I was in high school. And I just asked which degree paid the most when you graduated, and that's how I chose plastics.
Is that right? Which degree within engineering, or just which degree period?
Well, it also paid the most, I think, across that campus. I went to Penn State Erie, which is a sub-campus from Maine, and it had the highest starting salaries for graduates.
Interesting. Now, were you ever worried that, maybe this is going to have the highest salary, but what if I don't like it? Was that ever a concern?
No.
You always knew?
I didn't even know what a plastics engineer did. I had no idea. I originally thought I wanted to be an architect, and they had programs when I was in high school where you can go shadow architects, and I realized you have to have an artist flair to do that well, and I don't have that gene.
As many mechanical engineers lack, yes. So what does a plastics engineer do?
The focus was, I would say, a split between mechanical design, processing, and some chemistry. And I would say it was that mix pulled together. And it's an engineering technology degree, so it's more hands-on, it's more applied. And so you really ran a lot of stuff in the labs. You ran equipment, you ran test equipment, you ran processing equipment. You learned a lot about design. You learned a lot about simulation. So it was quite an eclectic group of talent. And everybody graduates. I got a job offer as a sophomore. The job market was so hot in the 90s that people were offering you a job as a sophomore.
Wow, incredible. I mean, these days you don't see degrees specifically for plastics engineering. You see mechanical engineering, you see electrical engineering, chemical engineering. Was plastics engineering kind of a rare degree even back then?
It wasn't the most common. There's a handful of schools, UMass, Ferris State, obviously Penn State. There's a lot of polymer science kind of schools. You can go for polymer science, but but doing it in the form of more design, more processing, those are rare combinations.
Yeah. Okay. Well, eventually you wound up at the company for whom you work now, Stress Engineering Services.
Yes.
Can you tell us a little bit about how did you get there?
I had so I worked for two large multinationals before joining Stress, and I worked for the first one I worked for two key people. Both of them left, and one went to another company where I went there first. So my first job out of school was with Procter & Gamble. And the guy I originally worked for left and went to Rubbermaid, vice president of Rubbermaid. So I went up to Rubbermaid and worked there for a handful of years. And the other guy I worked for came to Stress Engineering. And I watched the business cycles, and I realized that working for big corporations, there's a lot of upsides to that, but also with time, the companies change a lot, and their need for different skills changes, and so sometimes it's not your choice if you're going to be there the long term. And I just said, well, I'm not going to let that happen to me. So I was attracted to the services model because I really have, for the sake of discussion, I have 50 employers, which you have a pool of 50 clients, and so as long as you keep on doing a great job for them and looking out for them and making sure you're providing value, you will have a job the rest of your life. So I've learned the art of really understanding value for our clients, and I've really just adopted the services mindset. And I really, it's a gift that I got from a company that allows you a total freedom. I'm in year 18, and my job has been unscripted for 16 years.
What does a day in the life look like for you right now? Or is it just completely different every day?
A huge variety. I'm in a role now where really supporting a lot of the folks that are coming up in the ranks. What's interesting about this business model is it's not a zero-sum game. My goal is that the folks that work for me is they all become my peer, become my partner. So I focus every day on really driving the careers of the individuals here. As an outside looking in, we're an engineering services company, but inside these four walls, we're a people development company. And so I spent a lot of time on a variety of projects. And what's interesting is when you're a physics-based organization, you're almost industry agnostic because the physics are identical in all these industries. And so you will work in multiple industries in any given day. I'll work in oil and gas. I'll work in consumer products. I'll work in med device, and I'll work at pharmaceutical all before lunch. And that happens. And so it's a huge variety. There's never a boring day. I can guarantee you that.
It's interesting to hear you talking about the variety. When I talk to my team, we're a services company as well. And when I ask them, what do you like about working in pipeline? One of the most common answers is the variety of work that they get to do, right? At a big corporation, you might be doing the same thing every day, month after month, maybe even year after year. But in a services organization, like you said, you have 50 different customers or more, and there's always something different to do, which for me anyways, is very gratifying. Now, you've been there at SES for 17 years and change. That's a fairly long time to stay at one company. What has kept you there all these years?
Well, I'm an owner. And so if I want to complain about my boss, there's really no one to complain to. And so it is a model currently that's based on a partnership. So when you get promoted, you buy in, and the buy-in was more than the value of my last house, right? So it's a significant thing. Now I think we're a partial ESOP. We're heading towards probably maybe a model of 100% ESOP or something like that. But you're truly an owner. You're truly an owner, and that part I really like, right? And it's not that for the power, whatever else, but the freedom. I really do what I just want to do. I find my lane. If you read about anybody that's successful, you go watch any commencement speech of a successful person, any Hall of Fame speech of anybody in any sports, and they always have this consistent theme. I stayed in my lane and I did it really well. And that's what I encourage everybody here at Stress to do. That's what I do. If I'm good at it, I'm going to do it. And before you know it, I'm here every day at 7, and sometimes I don't leave to 7, and I don't even realize it, because you're just doing what you like.
What advice can you give to listeners who might not have as much freedom as you do, but who want to have that kind of role where they find what they do really well and they just keep doing that thing? Is that something that can be done in most companies to some extent, or do you really have to find a special organization, maybe a services organization similar to Stress, where they can do that?
I'm biased. I think that only a handful of people actually do that in a corporation. And, if you get to a fellow role after 30 years of working somewhere, maybe. But I would say if you don't control your future, someone else will. And, and for me, I spend a lot of time with the folks here thinking about what is your lane, what do you do well, and let's promote that.
Yeah. Over those 17 years, I'm sure you've encountered many, many projects. Can you share what has been one of the most technically challenging projects that you and your team have solved, without going into any confidential information, of course, and what was the process that you followed to solve that problem?
We deal a lot in the med device space with kappas. And I had a client that in the we'll call it the structural heart space, where they had multiple CAPAs on the same product over 5 or 6 years.
I'm sorry to interrupt. CAPA, corrective and preventive. Can't remember what the last A stands for.
Yes, it's generally a process that they follow where they identify the root cause and what they're going to do to address that. And so that's a term popular in probably many industries, but popular in the med device space, right? So it's a corrective action and preventative action, something along those lines there. This client was struggling with this. They had sent it to multiple firms, and we went through the typical process of what we thought caused the problem, and we came up with the same results that everybody else came up with, right? And so I came in because it racks my brain. So I come in. Well, first I always go talk to the rest of the brain trust in the building. I mean, I have 100 PhDs for colleagues. I'm like I work at a university, except for we get stuff done. And so, I talk to all of them, and sometimes they say, you just have to go out there and, play with the assemblies and see what's really going on. And so they were solvent bonding some components together and was breaking the tubing. And I went out in the lab and I was trying to recreate this problem. And, I was solvent bonding them and then putting them under a tensile right away and seeing if I can cause a tube to fail. And after a period of time, probably about 2 hours out there, I finally ran across a combination that actually can make it happen. So I started designing experiments around that and seeing if I could reproduce it, and I could. And then I went back to the client and I asked them about process changes that they'd done and what their control strategy was. And lo and behold, I stumbled on what actually really happened. This is one of those things with a little bit of adhesive is good, a lot is better. Well, in this case here, a lot caused a chemical attack and was causing a failure on the tube. And they had changed out, they were running some, Kaizen events or whatever, and they were trying to speed up and cut their cycle times down on manufacturing. So they usually let those parts sit for a period of time before they would put them in the packaging and put a sustained strain on the tube. And so you go and you're able to backtrack saying, I know this is the failure mode. This is the only way I can get this to fail. You've done this with, several other companies, and this is the only way I can get this to fail. Where would this occur? And we tracked down in the process where that would occur. We addressed it and the problem went away. I have a client for life.
Absolutely. Man, what a great feeling that must have been.
Yeah. I mean, and, if you just want to sit behind a computer all day long, you're not going to solve some of these problems.
Well, what is your process for product development like at SES? What are your teams doing there that other firms should consider doing?
I have, one of the advantages that we have is that we've become a clearinghouse industry for problems. So a third of our business is just dealing with problems, and we see the same problems over and over and over again. And it gives us a huge competitive advantage because in this building here, we have 100 people and we burn through 650 projects a year.
Wow.
Okay, so you see an awful lot. Some are really big, some are really small. But, so you can imagine 200 of those projects are just dealing with bad situation. And what you want on your team is not someone who's read about it or seen it, but done it. And so I like to sit way early on in the process with maybe the systems engineer or with the program manager and say, this is where you're going to have trouble here, here, and here, because we just see, we call them material failure logic models. We see the same combination of events lead to failure. And it's not about being critical and say, you can't make this happen, but it's about making sure that you have an engineered solution that will be robust. And so we follow the same process that everybody else follows from the FDA for med device, in the waterfall process. But I think the real advantage is seeding way up front in telling them where you probably need to spend extra effort. So I'd say that's number one. Number two is we're strong components of using predictive analysis and designing the part. You design for the design, the manufacture, and the use. So we will do advanced simulations on all those. And if you don't understand it, you can't simulate it and get it right. And if something does slip through the cracks, you can always go back and interrogate the model. And those are some, I don't think that that's as strong in the med device and pharma space as it is in the consumer product space, right? So the consumer product space has been doing this for a long time because they're concerning themselves with scale up from 0 to a billion or 0 to 100 million. Med device folks don't concern themselves with that, so they do a lot of build, test, fail cycles. And, there's better ways to go about doing that.
Yeah. You talked about some of these common areas that you've been able to see as patterns because you've seen so many of them. Are there a few of these common areas that lead to failures that you can share?
Yeah, absolutely. When they passed the Affordable Care Act, what that said is that if you get an infection in a hospital, the hospital is not going to be reimbursed for the incremental cost to treat that patient. So what you saw was cleaning protocols were changed within clinical environments, and they became more aggressive with the cleaning. Well, that caused environmental stress cracking on very common materials used in the med device space. And, one of the most common materials that everybody knows about is polycarbonate. And polycarbonate is bulletproof, right? And the dirty little secret about it is it can take a strong impact, but you put a little bit of load on there for a long enough period of time, it will break. And it'll be accelerated by things such as cleaners. The cleaners will accelerate that. So we saw a lot of CAPAs go through, and they're starting to wind down. The industry is not getting ahead of that problem. But we just saw a rash of those problems coming through the organization that's very common. And as part of that, you also saw that they're driving up the IPX rating. So you'll see it on your iPhone. It has an IPX rating. It tells you how much water you can expose it to, whether you can go down a meter, whether you can put it in a shower, or whatever it is. And so you see these systems being sealed up. So the systems then with these batteries inside are getting hotter, and they're aging the parts, and they're failing earlier. So you're seeing these kind of failure modes, right? And they're very common in the marketplace, and they still happen a lot today. And so there's an example of one that's very, very common. The other is really how sterilization affects materials. People still run into a lot of problems with sterilization. It's very, very common to run into sterilization problems, and they have a negative impact on the material.
Those are great examples, and I could see how if you weren't privy to seeing those so frequently, it could take a team, weeks or months or longer to figure out what's really going on. But because you guys have been able to see these same problems so often, you're probably a lot faster at diagnosing those than other organizations.
Yeah, if I can add to that, engineers they often have a lot of pride, and they don't want to call for help, right? So you realize, that we get the phone call and they've been struggling for 6 months. And, now, if I'm presenting in person, or now you're doing it with, Teams or whatever. And I'd ask them, well, does it look like this? And I'll bring it up on the screen, their failure mode, because they'll just describe it to me. And I'll know within a handful of minutes probably what's driving that problem, because I've been there and done that before. And it's really about the remediation. I say, does it look like this? And they go, how do you know? Well, it's my job to know. And so it looks like this, and they're trying to get their bearings on why it's happening. And I start talking about how we're going to fix it. And they're like, oh, wow. And again, one of our, we have lots of clients, and it's not unusual that our first interaction with a client is they got a problem. And then they realize that, hey, there's value for you to add here. Most of our clients, we deal with the top 20 in med device, pharma, consumer products companies. They all have tremendous resources. But what they don't have access to is all those tremendous resources on a dime. And so we can just give it to them right then and there. They bring you in. They want you as part of their team. And we just help them drive through and get the product development done.
Yeah, I can attest to that. Having worked with several large medical device companies ourselves, they are, in general, much more concerned with getting something done quickly than they are with how much it costs. To a point, of course.
Yeah. I mean, you set up your rate structure commensurate with the value that you give to your clients. And so, when a third of your business is the emergency room, what that means is that we have to have all these resources. All these people are getting W-2s from Stress Engineering. We have all these labs They're there to be used at a moment's notice based on that need.
Well, that's a great segue into my next question. What are some tactics or best practices that the best product development firms out there, the best engineering services companies out there follow to ensure that they remain profitable?
Yeah. So device development is broad and long. It requires you to do 1,000 different things. It also requires people who have done technical things 1,000 times. All right. And so it's not about pride, but recognizing who's been there and done that before. With time, all I care about who on my teams is like, who's been there and done this before so we can drive this through. So those that recognize that do that well. And we see we have certain clients, certain med device companies that we would all know. Some of them are highly vertically integrated internally and they build those systems. Other ones have like a skeleton crew where they fill the rest with either contractors or services companies. They're both trying to accomplish the same tasks in different ways, but really you want those folks that have been there and done that before. What's very common though, you go in a design review and they generally bring the person who's been around for 30 years in the back. And they sit there and you're presenting all this stuff and you're all happy about it. And then they say 2 comments and I'll get shut down in a moment's notice, right? And there, a lot of us have been there before. Well, let's not get to that point. Let's make sure the people on the team have been there and done that before. And I refer back to the systems engineering role when you're developing your requirements and you're also seeing through how am I going to verify these requirements? How am I going to validate this product? And you're thinking through all that up front. And those that manage that better tend to have less problems. And, I think because I can run down the reasons why failures occur, but I'll walk through, there's 4 big items that drive failures in product development.
Are you going to tell us what those 4 are or hold us in suspense?
Oh, I'll go through those. So I spent a lot of time after, you get a phone call and you go work with a client to get them across the finish line. And, maybe they had some problems along the way. And I'll ask, how did you get here? It doesn't show up on an FMEA. It doesn't show up on a fault tree. It doesn't show up anywhere. The simple answer is almost always, I didn't know I needed to know that. Number 1. All right. Number 2 is key stakeholders talking past each other. There's a push to push the development down into the supply chain. And when you look at failures, if I have a failure and I show it to a design person, they'll tell me it's a design problem. I take it to a materials person, they'll tell me it's a material problem. I take it to a manufacturing person, it was made wrong. And then my more favorite one recently is I take it to human factors and it's a use error. And, well, who's right? Well, the fact is they're all right. But if you have an injection molded part and it's failing, what I see is they go to the person who made the part and said, well, you're an injection molder. You should understand mechanics and materials and human factors. And they don't. They're really good at manufacturing. You should rely on them for manufacturing. But they'll ask them, do you know about plastics? And they'll say, yes, we do. And they go, well, that's fantastic because we have a plastic part and we need help. And they're all talking past each other and they don't realize the limitations of their conversation. That is the number 2 driver of failures. Number 3, I see the reinvention of the wheel every day. All right. There's this constant need to reinvent the wheel. And they're going up these learning curves. That's why you want someone who's already been up the learning curve. They go up the learning curve and you're like, hey, listen, that problem's been solved over here. And the 4th reason, often very controversial, is rapid prototyping. Rapid prototyping gives you overconfidence too early, especially when you show it to someone who doesn't know a lot about development. They go, it's there, just go. And I see that a lot. So there's an over-reliance on rapid prototypes to build confidence in that we can move faster. And, and I see that a lot too. So those are often, if I had to boil it down to the 4 drivers that often drive a lot of failures and this comes from looking, I like to do failure. I always tell people my nickname is Winston Wolfe. Now, for those that don't know who Winston Wolfe is, that's the cleanup guy from Pulp Fiction. 30 minutes away, be there in 10, right? You see a lot of problems all the time, and you start going, yep, they did that. Yep, they did that. They did that. And, my favorite thing is that, I know how much it costs to do the work that they needed to get done that they should have done, 6 months ago. A lot of times it was probably a $5,000 task that could have saved them $1 million. And I see that a lot.
Wow, that's incredible. Ouch. All right. Well, this is a good place to take a quick pause and share with the listeners that teampipeline.us is where you can learn more about how we help medical device and other product engineering or manufacturing teams develop turnkey equipment, custom fixtures, and automated machines to characterize, inspect, assemble, manufacture, and perform verification testing on your devices. We're speaking with Robert States today. Robert, you have personally investigated and interacted with over 30 different services firms, from engineering to marketing to product development. Are there any common threads or patterns that you've seen amongst them all?
The most successful people are the ones that learn how to develop strong relationships with their clients and understand their clients' needs. If you want to go sell your capabilities, if you want to go do a capabilities presentation, you're going to narrow your scope. If you want to provide a solution to the clients, it'll grow. So those that really capture that essence of that, they have the most amount of success, right? The other thing is they stay in their lane and they stop telling the world they can do everything. Well, I once did that, 30 years ago. I could probably, dust off the book and figure that out. It's like, hey, if that's a part of a bigger scope of work, great. But to go be that first interaction with a client, not a good idea.
Well, it goes back to the learning curve that you're talking about, right? All of a sudden, you have to climb this giant curve in order to get the job done.
Yeah. Listen, during the peak of COVID, the unemployment rate for an engineer was 3%, right? There's no shortage of need in the marketplace for engineers. Be who you are.
Well said. Well, what tools are gaining traction in the development phase of a device or a piece of equipment? What tools are you seeing commonly being used these days?
In the consumer products industry was on the forefront of using predictive analysis because they were trying to drive out costs, and they built automated tools going back 30 years ago. They got to have an app for your iPhone at this point for this. But it's interesting, in aerospace is only done this way. Offshore oil wells are only done this way. It's all done with predictive analysis. You can't prototype that stuff. But what you find is the med device space is like lagging that industry by literally 20 plus years, right? You will see them do it for orthopedic implants and heart valves because, again, that's hard to prototype. But the rest of it is not fully accepted in the marketplace to the extent it is in other industries. And that's a huge opportunity. And the FDA recognized that, and the FDA is pushing on this to drive competitiveness in the United States. And so they provided guidelines a handful of years ago on how to do this. I've had opportunities to go visit the FDA, and I've seen some of their data where they go off and run, round robins of testing and analyses, and they get the data back, and they showed me some of the variability. It was highly variable. And so that's the problem that the industry struggles with, is how do you use these tools and know that you have a regulatorily grade solution? And so that's what's coming out. And so, you should expect to see this grow, right? The pharmaceutical industries do this for the drug development. I mean, they have just loads and loads of PhDs that are really deep. But I say, well, why don't you go use this on your med device? Nope. On our drug delivery system? Nope. That's someone else's problem. So, they recognize the value, but they won't invest in it. So that creates the opportunity for a lot of other companies in the marketplace. So you're gonna see that to continue to grow in terms of supporting development. And in those that use predictive modeling, such as FEA or CFD, they might use it in the development phase, and it sits on the hard drive collecting dust for the rest of its life. And what you should expect to see, those models will have life through the product life cycle, where you're going to be running digital twins of the manufacturing process and the use. Compare that against the predictive models. And you're going to be able to use that to drive quality and drive long-term reliability.
Can you talk a little bit more about the digital twins? What are digital twins and how are they used?
So if you have enough people listening to this, they'll say I get the definition wrong. So it's used by a lot of people in a lot of different ways. But in the context that I'm just going to describe it is that if I was putting a plunger into a glass syringe, and if I'm able to take a picture of that plunger and I know the profile and I know the ID because I can measure the ID somewhere online for a given syringe, I should know that I should be able to highly predict the force to insert that plunger into the syringe. Okay. And today it's all done statistically and it actually failures get through. I can tell you all about them because I see them. And stuff gets through and they're buying like stock components from companies like West or like Dotweiler or BD, right? Everybody does that. It's a very smart move. It's a great thing to do. I'm all in favor of it. But they have all those three companies, for instance, are trying to satisfy, 50 other pharma companies who all have their own requirements and everybody's trying to figure that out. But if I know that force to insert that plunger in there should be, I'm making up numbers here, half a pound, right? And I know that force should be that, and I know the dimensions are correct. So I've done a model. I calculated it on the edge, right? So I calculated that I measure these things. I should be able to put this together. It should be half a pound, and it comes out that it's 3/4 of a pound. You go, maybe there's no siliconization up there. Maybe something happened there, and you should be able to do that digital twin there and know what that force should be. And because you may be measured in line, online metrology is something that's coming along, and you're able to then do that calculation because you have the predictive model in the background. You build the regulatory grade models, and you can see these things, and you can check against it. They might all be dimensionally correct. They go all the way through the system, yet if you were going to go look at the force to activate that syringe, it's going to be high and maybe not acceptable. And so you should be able to do all that forensic exam on that device before it leaves the line. And that's how I would use digital twin.
So, restating that, digital twins are when you're performing a test on a physical component and you get whatever result you get based on that physically performed test, then you compare it against your predictive model, your FEA or your CFD, and you compare those results. And if they're significantly different, then that gives you pause and you say, hold on, something's not matching up. Not sure if it's on the digital twin side or on the physical side, but something's not matching up. Let's figure this out. Is that accurate?
Yeah, and I can take it a step further. If you're familiar with bathtub reliability curves, reliability gets better after, in initial phases after you launch. It's steady, then reliability gets out of control again, at some point in time as things wear out. And so everybody understands how to handle early on reliability issues, right? Everybody has that built in their system dealing with it. I mean, I know there's better ways and some companies are better at it than others. But the one that all of a sudden product that's been in the market for 10 years and everything's in spec, but all of a sudden they have problems. Right? We see those two, probably about 1 a quarter. And you go, what happened? What happened? How do I find that problem? So, you go, PAC Expo's going on, and you go there, and all these people have these signs say Industry 4.0, and you go up and say, what does this mean to you? And they're like, oh, well, we can provide you 8 terabytes of data a day. Okay, what am I going to do with that? And so I think the real opportunity here, as I talked about the digital twin, is that you should know what the force should be, right? And actually, your thing is that if it doesn't match, you either interrogate the model or you interrogate the part. So if I have a statistics-based model, there's a lot of information companies out there like SAS and others who will, do the data science and they're statistically looking at that process. And my thing is this: when the physics-based model and the statistics-based model diverge, that's when you get those late stage reliability issues, late product life reliability. Okay. And you can predict those. And remember, what's the number one reason why I have a failure? I didn't know I needed to know that. So there was something in that physics-based model that didn't capture that behavior. And it prompts you to go look for it. And, so the statistics-based systems don't work until you made 1 million products. I'm just making up numbers here, but you don't know until you reach some sort of steady state. When you seed from day one with a physics-based model, you can provide confidence that that product is good, and you're going to learn about what's really driving your reliability, and you can predict when it's going to be problematic sometime down the road. And I really think that's a true opportunity in the marketplace. And I know companies are trying to figure this out. I talk to them. They all have interest. And I go talk to the individual units. I'll talk to quality, regulatory, sustaining engineering folks, R&D folks, operations folks are all on board, but none of them have the political capital to make it happen. So it really has to happen from the top down. And I would say the industry is in flux on how that's going to happen. I just know of case studies that we're involved with where this is happening, but this is coming.
We've been talking about failure a lot during this episode. Share with me, how does organizational structure drive failure?
Yeah, there's a couple of things there. If you are highly vertically integrated and you have a relatively young staff, you don't have enough people there to have seen enough, right? You have to have that mix. And so if you have an organization that regularly burns through people, and there's companies like that, we all run across them, there is no one that's been there and done that holds that tribal knowledge, right? And so you really need access to that tribal knowledge one way or the other. So if your structure is to be highly vertically integrated and you have a relatively inexperienced staff, even if you have a handful of experienced people on there, they can't capture it all, right? You need to be diversified there, as opposed to a model where you rely heavily on expertise on the outside. And I always tell people, I'm never going to understand their products or their customers as well as they do. But, outside people can provide an equal perspective if they've been there and done that. I've worked on, 50 different platforms for drug delivery systems. So, bring me number 51. There's probably not something there I haven't seen before, right?
Right.
So they don't need to run the project. You only need them for a small percentage of them. Let them help you identify where the problems are going to be and accept that help. And it will go a long way. So, and sometimes you have, big corporate entities. I can tell you that, we get phone calls all the time where, again, the capabilities of some of these large multinationals is huge. Their share price moves more than the value of stress engineering every day on the stock market, okay? But they can't motivate their colleagues to help them. And so, you need to have a model that provides a lot of freedom to the people to get the job done right, and then teach them about what right is. And, so I would say, I see how the different organizations have, and here's the net result. I can just tell you, if you're buying services, it's a lot cheaper to prevent it than deal with it later. They never ask me how much it costs to fix it, but they're always asking for detailed proposals to help them up front. And hey, I get it. It's a capital society. This is what we're going to do. But, I can just tell you, I guarantee you it's a lot lower cost to do it up front.
To put the time in to do it right now, right?
Yeah.
What's the saying? It's there's always time to, or there's never time to do it right, but there's always time to do it again.
Yes, that's right.
All right. Well, I think we'll wrap up here in just a few minutes. I've got one or two more questions for you. What are one or two of the biggest challenges that you face at work?
It's important to keep clients happy, and you have no throttle on whether you're going to get 4 phone calls today, 10 or 1 or 0. And so you're always trying to manage that. And that is probably the most difficult part, is just manage that. And because it's key that you keep them all happy, that they come back. And so I'd say that's probably, the biggest challenge. The other one is in this aspect of this role is there's a business development aspect that there's a high spirit of entrepreneurship here. That's very hard for engineers. I remember I was forced to take an entrepreneur class in college, and I said, I'll never do this. I'll never do this, and I lead a lot of the business development activities. So, so that's a difficult, I live for it now. I love it, but that's hard for a lot of people.
Yeah. Yeah, that's hard for me to wrap my head around as well, because that's the part I love, the entrepreneurial part. But not everyone's built that way. And actually, that's a good thing, right? The world doesn't need everyone to be an entrepreneur.
Yeah. I segment our folks from, I draw a bell curve distribution. On one end, you have really what I call the SME squared, or the fellow. And on the other end, you have really the visionary. And then I have a spectrum across that where I broke it up into 6 segments, and I really spent a lot of time with the individuals and figuring out, what are you? Are you in the middle? Are you on the left? Are you on the right? It doesn't, the answers are all correct. What's important at Stress is that all of them are important. All of them. There's no greater among them. And I like, okay, this is your lane. This is what good looks like. This is how we're going to develop you in your career. And, we want you to go pursue this and love what you do.
Yeah. Okay. Well, before we wrap up here, is there anything else that we should have talked about that we haven't yet?
No. I can just tell you that product development doesn't have to be as hard as it is that a lot of people are experiencing, right? So, be open to other ideas, and you should explore them and go and find people you can trust. The number one piece of advice, I told you my job's unscripted here, but I always tell people, surround yourself with people who've been there before and listen to them.
I love it. All right. Well, Robert, thank you so much for joining me today. I really appreciate you spending some time on the podcast.
Oh, this is great. I really appreciate it.
I'm Aaron Monker, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing turnkey equipment, custom fixtures, and automated machines, and with product design, visit us at teampipeline.us. Thanks for listening.
Dear valued listener, we kindly ask that you help us get to 100 5-star podcast reviews in the platform of your choice. For a chance to win a $50 Amazon gift card, send a screenshot of your 5-star podcast review to podcast@teampipeline.us. You'll find that email address in the description of the show notes.